Okay, today we move into section 6.2, and today we will add and subtract rational expressions. We've already discussed multiplying and dividing and simplifying rational expressions. Now we move into something a little more challenging, which is adding and subtracting them. Okay, go ahead and try these warm-ups. Pause the video, see how you can do. Okay, number one, just adding fractions. Since you already have a common denominator, you just add the numerators. 3 plus 5 is 8. Look down at number 3 here. Our denominators were 3 and 2. We needed to get a common denominator first, which would be 6, since that's the smallest number that 3 and 2 go into evenly. So I multiply the top, or the first fraction by 2 over 2, and the second fraction by 3 over 3. You end up getting 8 6 minus 21 6, and you get negative 13 6 now that you have a common denominator. What we're going to be doing today is adding and subtracting rational expressions. Okay, so warm-ups numbers 2 and 4 are like warm-up number 1 here, where the denominators are the same. That's the easier case. For the rest of the lesson, the denominators are different. So we're going to be doing something like warm-up number 3 the rest of the lesson, and that's where it gets a lot more difficult. So you see in warm-up number 2, these denominators are already the same. So you just keep that same denominator, common denominator, x squared plus y squared, and you just add the numerators. Combining your like terms, 4y plus 3y is 7y, 7 minus 5 is positive 2. Same thing over here in number 4. The only thing you have to watch out for is, since we have a minus, since we're subtracting here, you have to distribute the minus to all terms in that second numerator. So positive x squared becomes minus x squared, negative 19x becomes positive 19x, and positive 4 becomes minus 4. Then you collect your like terms, and your final step, just like we discussed in section 6.1, how you have to simplify rational expressions, you need to continue to simplify this. You need to try to factor the numerator, factor the denominator, and cancel out common factors. But you'll notice in this numerator we cannot find factors in negative 13 that add up to 24, so we are done. Does not factor that numerator. So these are the steps that we are going to go by in adding and subtracting rational expressions for this lesson. There are 7 of them, and if you look at warm-up numbers 2 and 4, we basically just did the last 3 because the denominators were the same. But when the denominators are not the same, we need to do these first 4. Okay, so we are going to, the main thing is getting the denominators being the same, and identifying the LCD is the first, it's probably the most complicated step that we'll see. The only new thing here. So I want to talk about that step first, and then we're just going to follow these 7 steps as we go through and try some examples. And that second step is summarized right here as we go through and read through all of this. It says to find the least common multiple of 2 or more algebraic expressions, we first factor the expression. So what we would do is, that's why step 1 says to factor the denominators. And then we look at the factored form. We identify each factor, the greatest number of times that it occurs in any of the factorizations, and that's basically just saying that the largest exponent that we see for any common factors. So if we look at example 1, this isn't the normal way that we'll see it. We'll normally see these expressions as denominators. So what we would do first, step 1, it says factor them. So we would factor x squared minus y squared. We would factor x cubed plus y cubed. And we would factor x squared minus 2xy plus y squared. Okay, so once I have everything factored, I can identify my least common multiple in this case, since they aren't denominators. When we see them in an actual problem, they're going to be denominators, so this would be called the LCD, least common denominator, but for now it's least common multiple. The way we identify it, we look for all the factors that occur. So for instance, I have an x plus y. I see it once in this factorization, I see it once in this factorization, and I don't see it at all in this factorization. So the greatest number of times I see it in any factorization is 1 time. So I put it down once. Another factor I have is x minus y. How many times do I see it in this factorization? I see it once. I see it 0 times here, and I see x minus y twice down here. So the greatest number of times that I see it in any factorization is twice. So x minus y squared would be part of my LCM. And then finally, the only other factor that I see is this trinomial x squared minus xy plus y squared, and I only see it once. That's the greatest number of times that I see it, so that will be part of my LCM. So what I would do in an actual problem is I would try to then make all of my denominators be this common denominator. And we will move on how to do that next. Okay, looking at example 2, we are adding and subtracting some rational expressions with unlike denominators. So we go through the 7 steps. The first step is to factor the denominators, which they are really can't be factored anymore. I mean, I could do a factor tree on 8 and 12, but these are easy enough numbers. I can pretty much skip straight to step 2 and identify the LCD, the least common denominator. The LCD, I need to find the smallest number that 8 and 12 go into evenly, which is 24. Another factor that I have in the denominators is a. I see it once here. I see it 0 times in this denominator. The greatest number of times that I see it is once. So 24a is my LCD. That basically means I'm going to make both of my denominators look like 24a. So let me just rewrite it here, and now I need this denominator of 8 to be 24a, so I need to multiply it by 3a. And whatever I do on the bottom, I have to do on top as well. So multiply top and bottom by 3a. Here I just need to multiply top and bottom by 2. My next step is to just multiply these. So 3a times 7a is 21a squared. I am expanding my numerators. 24a plus 10b over 24a. Now I have a common denominator. I can go to step 5 and can combine it to be a single rational expression. Just add my numerators here. 21a squared plus 10b. There are no like terms to collect, and there's no more factoring to do. So I'm done. Number 2 gets a little, or letter B rather, gets a little more challenging. We do need to do that first step and factor the denominators, because we can see that this denominator does factor as the difference of 2 squares. Next, I can identify my least common denominator. I see I have a 2. I have x occur only once. Now remember, even though I see x twice in this denominator, remember x here is a term, while x here is a factor. This is part of a factor. This factor is actually x plus 1, and this factor is x minus 1. So the greatest number of times I see the factor x occur is once in the first denominator, 0 times in the second denominator, 0 times in the third denominator. So the greatest number of times I see it is just once. The greatest number of times I see x plus 1 occur, I know I see it a total of 2 times, but the greatest number of times I see it in just one denominator is once. So I put it down once, and same with the x minus 1. So now that's my least common denominator. Step 3 is to make all of these denominators look like my LCD. So this 2x is missing an x plus 1 times x minus 1, so I'm going to multiply top and bottom by x plus 1 times x minus 1. My second denominator is missing a 2x, so I'm going to multiply top and bottom by 2x. And my third denominator just has an x plus 1, so I still need a 2x and an x minus 1, top and bottom. Okay, so now that I'm going to have the same denominator for each of the 3 rational expressions that make up this problem, I can start expanding the numerator. So my first numerator, I am going to FOIL the x plus 1 times x minus 1. The second numerator will just be 5x times 2x, which is 10x squared. And then the last numerator, I'm just going to distribute the 6x to the x minus 1. Okay, my next step is to write it as a single rational expression. And I am also going to collect my like terms as I do so. So my x squared plus 10x squared plus 6x squared is 17x squared. My linear terms, I only have a minus 6x. And then my only constant is a minus 1. And then my denominator will just be my LCD again. And I would look to factor the numerator to see if maybe I can get some of these factors down here to cancel out. But in this case, the numerator does not factor, so I'm done. Moving on. Okay, first thing I'm going to want to do here in letter C is I'm going to want to factor the denominators. Then I'm going to want to identify my LCD, which in this case is just y minus 6, y minus 1, y plus 1. Then I'm going to make each of these denominators look like that LCD. So this first denominator is missing a y plus 1, so I'll multiply top and bottom by y plus 1. And then the second denominator is missing a y minus 1, so I'm going to multiply top and bottom by a y minus 1. Okay, now that I'm going to have the same denominator, I'm going to start to expand my numerators. So this first numerator, 2y plus 1 times y plus 1, I will FOIL. Same with the second numerator, and I'll just keep the same denominators. Okay, now I can combine it to be a single rational expression. Since we have the same denominator and our numerators are expanded, just make sure, be careful here with this minus being here. Make sure you distribute the minus, as we've seen in warm-up number 4, to all terms of this rational expression. Then we can collect our like terms in the numerator. We would get y squared plus y plus 2 over our common denominator. Actually, it was plus 4, not plus 2. And then you would try to find factors of 4 that add up to 1, and unfortunately in this case it doesn't go any further, so we can't cancel anything else out, so you're done. Now there is a little trick in letter D. Whenever you try to factor the denominators, the first denominator is x plus 2x minus 2. Now you'll notice the second denominator is a 2 minus x, and that's not the same as x minus 2. So I would like this to look like x minus 2, and I can do that if I factor out a negative 1, like I did right here. So the basic shortcut that you can do for this, anytime you need to switch these around, the subtraction like that, just change the sign that's out in front. See how this was a plus? Just change the sign, so now I'll change it to be a minus, and then you can flip these around. And now I have the denominators factored the way that I want, and I can identify my LCD to be just x plus 2 times x minus 2. So I'm going to make the first denominator look like that. It already does. The second denominator needs an x minus 2. And the last denominator needs an x minus 2. Okay, we can go ahead and expand the numerators, and you'll see as time goes on and you get better at these, you can maybe start combining steps at once. So I'm actually going to expand my numerators and write it as a single rational expression at the same time, combining two steps into one. Okay, so just make sure you're careful with that. Notice what I did was I distributed the negative along with the 5 to get a negative 5x plus 10, and I also distribute this negative along with the 1 to get a negative x plus 2. Now combining my like terms, 2x minus 5x is negative 3x, minus x is negative 4x, and then my constants give me plus 12 over x plus 2 times x minus 2. Whoops, I just caught a mistake that I found. Here's the mistake. Hopefully you already saw that. I need my denominators to be x plus 2, x minus 2. I already had an x minus 2, so these should have been x plus 2. So let me go ahead and fix all of that. Okay, I think we're back on track here because I now see that my numerator does factor further. This is the one that actually does go further. We can factor out a negative 4, and I'm left with x plus 2 over my common denominator of x plus 2, x minus 2. And now finally I got one that went further. I have some common factors that cancel out the x plus 2's, and I'm just left with negative 4 over x minus 2. And that should take us to the checkpoints.